In the previous example, we looked at how we could try to factor a given function or a given equation to make our lives a little bit easier when trying to figure out if that function has two unique solutions, one unique solution, or no solutions. But as we see in this case, it says if integral roots cannot be found, estimate the roots to the nearest tenth. And so that kind of gives us an idea that maybe in this case, when we try to factor this, it may not be factorable, and we may have to use some of our other tools to figure out how to solve this by graphing. So one of the tools that are available to us is the use of our calculator. And so what we want to do first is check to see if this thing can be factored, okay? And so a couple things we always look at regardless of if we're factoring or not. Our leading coefficient is positive because it's already in standard form, so you can tell that because there's a 1 in front of the x squared. This means this graph opens upwards, which means our vertex is a minimum. So we know that right off the bat. The next thing we want to do is we can check our axis of symmetry, just because we may need it later. And that formula is negative b over 2a. And so b in this case, so I write the minus because that's part of the formula. B in this case is a positive 6 divided by 2 times 1, that was the leading coefficient, which gives us negative 6 divided by 2, which is negative 3. So we know at least that our vertex is a minimum. We know that our axis of symmetry is at minus 3. That's where the graph is basically split right down the middle. And if we really wanted to at that point, we could figure out what the vertex is. So if I plug in this into my equation, I can tell some information. So I have minus 3 squared plus 6 times minus 3 plus 6. And remember, we're solving because this related function for this is x squared. The related function is x squared plus 6x plus 6 equals y. That's the related function to this equation. And so I'm going to plug in my axis of symmetry x value to find the y value. So I get positive 9 minus 18 plus 6. So positive 9 minus 18 is minus 9 plus 6 is equal to minus 3. So it just so happens that our vertex is going to be at, well, we plugged in minus 3 for our x, and we got out minus 3 for our y. So it just happens that our vertex is at minus 3 comma minus 3. So that at least tells us and gives us a general idea of what's going to happen to this graph. And so just so I'm not doing this all in my head, this is not an accurate graph, but I just get an idea. Our vertex is at minus 3, which is here. And since it's a minimum, I know for a fact that the graph opens upwards. So at some point, this graph is going to cross the axis. And it's going to cross the axis twice. So I know I'm going to get two unique solutions. And I can tell all that just by finding that the vertex is a minimum, looking at my leading coefficient, and figuring out what the vertex is, okay, and where it is. I can tell all of that information just by those two pieces of information. But now what I need to do is I need to figure out a way of what the actual roots can be, and if I can't figure them out exactly, I can at least approximate them with my calculator.